In this video, we are going to use transformations to graph this function here of g of x. The first thing I would like to do is to determine what the parent function is. And the parent function will be when you strip away all the transformations that you see. So the parent function for this one I will call f of x would just be root x, because the negative 1/3, the negative 2, the minus 4, and the plus 3 are all transformations. Now I will get a set of values for this parent function, and I will use those values to get g of x by transforming them. So I'll pick values for x that are would easily give me values for y. The square root of 4, 9, and 16, etc. This is plenty in order to get the coordinates for the graph of g of x. Now the first one we're going to look at is inside the square root. We've got several things going on here. The minus 2 and the subtract 4. The minus is a reflection. The 2 is a horizontal compression, and the minus 4 would represent a translation left and right. Now in order for this to work the way I'm going to show you, and you must always do this, is to factor the minus 2. And that would change this to minus 2 quantity x plus 2. By doing this, this will look more like what it should when you graph it. Okay, so after we've factored it, we're going to do the transformations left to right. Now this minus 1/3, there's two things going on there. The minus sign, which is a reflection over the x-axis, and the 1/3, which is a vertical compression. So to reflect over the x-axis would change the values of y to their opposite. In this case, the 0 would stay the same. That is what the minus in front of the 1/3 will do. Now the 1/3 is a vertical compression, so that means I am going to make all the y values 1/3 of what they are now. So 0 would stay 0, but negative 1 would become negative 1/3, negative 2 would become negative 2/3, negative 3 into a 1, and negative 4 would become negative 4/3. You can actually do both of those at the same time by just simply taking the 4 black coordinates that you see and multiplying by negative 1/3, and then you would have those coordinates there at the end. Okay, now the next transformation is here. Again, I have a negative in front of the 2. Now since it's under the square root, that represents an x transformation. So this reflection would be over the y-axis. So the x's would become their opposite. And also the 2 is what's called a horizontal compression. Now if you think about it, if you compress horizontally, you're going to get closer to the y-axis, not further away from the y-axis. That would be stretching the x-coordinates out further. So we're actually going to divide by 2, not multiply by 2. And as I said before, you can do the 2 steps in 1 on the y's. We're going to do that to the x's here. So I'm going to take care of the negative and the 2 at once by dividing all of the x-coordinates by negative 2. So that would be give you these coordinates. Okay? The next transformation you see left to right is the x plus 2. We've talked about this many times. X plus 2 is a shift left. So if you're shifting left, you're only affecting x. How are you affecting x? You're making them 2 less, because left on the number line makes them smaller by 2. So I will subtract 2 from all the x coordinates. Minus 2, minus 2.5, minus 4, minus 6.5, because minus 9/2 is minus 4.5, and minus 10. And then lastly, the plus 3, that is a vertical shift. Up 3 would add 3 to the y coordinates. So this would become 2 2/3, 2 1/3, 2, and 1 2/3. So we've taken care of all the transformations. Now, to graph it, we will use these final coordinates, which would be -2, 3, -2 1/2, 2 2/3, -4, 2 1/3, -6 1/2, 2, and -10, 1 2/3. You graph those 5 coordinates, you will have the graph of g of x using transformation.